If you want to understand exactly how the tectonic plates of the AI world are shifting right now, well, you're absolutely in the right place. Today, we're looking at a truly disruptive model from researchers at Stanford University that completely changes the narrative on what it actually takes to build a highly capable artificial intelligence. Okay, let's dive into this explainer. $600. Let that sink in for a second. In the world of large language models, we're totally conditioned to think in terms of millions, right? Millions of dollars, massive server farms, and months of computing time to train models like OpenAI's GPT series or Google's flagship AI. But Stanford researchers managed to replicate high-level conversational AI for less than the cost of a new smartphone, or, about a day's rent in San Francisco. They pulled off this staggering feat using just 8 A100 GPUs. In the realm of deep learning, that is an incredibly modest hardware setup. It's literally a massive paradigm shift, proving you don't necessarily need a bottomless corporate bank account to play in the big leagues of artificial intelligence. Section 1. Meet Stanford's Alpaca. Think of this as our David versus Goliath story, introducing a small but mighty contender in the AI landscape. On one side of the ring, you have these massive tech conglomerates with seemingly infinite resources. And on the other are David, a lean project called Alpaca. So what exactly is Alpaca? Well, it's an instruction-fine-tuned 7 billion parameter language transformer. But the absolutely crucial part here is its foundation. It's built on Meta's 7B LLaMA, which dropped in mid-March of 2023. Now, LLaMA is a highly capable foundation model, basically a raw engine of language comprehension. But right out of the box, it kind of struggles to follow specific instructions or hold a helpful back-and-forth conversation. And that is exactly where the instruction fine-tuning comes into play. The Stanford team, they didn't build the entire engine from scratch. Instead, they took Meta's powerful open-source engine and figured out an astonishingly cheap way to teach it how to be a helpful assistant. Moving on to Section 2, the training recipe. Let's look at the actual mechanics of how this micro-budget AI was built without blowing millions of dollars. So how exactly do you take a raw language model and turn it into a refined, instruction-following AI on a shoestring budget? The traditional Goliath method is RLHF, or reinforcement learning with human feedback. That requires hiring literal armies of human workers to write out prompts, read the AI's answers, and manually score them. It's incredibly effective for sure, but man, it's slow, resource-heavy, and fiercely expensive. Alpaca's lean approach bypasses all of that entirely, using a supervised method with 52,000 machine-generated pairs. And this brilliantly illustrates the core innovation here. Instead of paying human beings to generate all those instruction and output pairs, they found a much faster, automated alternative. But wait, where did those 52,000 training pairs actually come from? They didn't just magically appear out of thin air. The Stanford team quite literally used a Goliath to train their David. They systematically queried OpenAI's GPT-3-based TextDaVinci 003 model. Basically, they set up an automated script asking the more advanced AI to generate tens of thousands of examples of good instructions and high-quality responses. They automated the human annotator completely out of the equation. So that $600, they spent that just paying for the API calls to GPT-3 and the minimal computing time needed to process it. Seriously, how clever is that? Now, in the technical literature, what Stanford did here is a flavor of what's known as knowledge distillation, or weakly supervised fine-tuning. Let's break down that dense technical jargon for a second. Think of GPT-3 as a master teacher who's spent decades studying every single book in the world. Alpaca, on the other hand, is the bright, eager student. Instead of making the student go to the library and read all those books from scratch, knowledge distillation simply allows the student to study the master teacher's highly condensed, perfectly written flashcards. The smaller model learns directly from the larger model's outputs. It is just an incredibly efficient shortcut to high performance. Section 3, surprisingly competitive results. Let's move to and see how this builds into the ultimate payoff of this open source recipe. Because let's be real, having a clever, cheap training recipe is really only half the battle, right? Does it actually perform out in the real world? Well, the researchers made the recipe available to the open source community, and the findings are a massive wake-up call to the entire industry. Just listen to this quote derived from the underlying research in the Self-Instruct paper. Bootstrapping a model on its own generations can result in performance competitive with Instruct GPT. I really want to emphasize that phrase, performance competitive. Instruct GPT is a highly sophisticated, human-trained model, yet this bootstrapped, cheap machine-annotated method absolutely holds its own. It proves you can completely bypass the million-dollar human feedback bottleneck and still produce a top-tier, highly capable AI assistant. Which brings us to the ultimate takeaway from this entire explainer. We've seen the 8 GPUs, the $600 price tag, and the brilliant knowledge distillation from larger models. But I really want to leave you with this final provocative thought to consider. If an AI can essentially train itself to expert levels for just $600, what happens when anyone, any startup, any university student, any developer sitting in their garage can just build one? The democratization of artificial intelligence, it isn't some distant future event anymore. Because of projects like Stanford's Alpaca, it's happening right now, today. Thank you so much for joining me, and I highly encourage you to keep exploring the incredible pace of open source AI.